So now let's do the following problem. I want you to prove that f from R to R defined by f of x equals 2x plus 3 is a function. So here we're trying to prove that this is a function, which means you need to refer back to your definition of a function. And I'll say, remember there are two conditions in the definition, so we must prove two things. And those two things are I, the first part, and the second part from the definition. So I'm going to write the two parts that we've got to prove here just so we have them to reference. So I says for all x in A, well RA is R, there exists a y in R such that f of x equals y. So we're going to think for a minute on the outline of our proof. We're going to take x to be an arbitrary real number because of this part right here. We have a for all symbol, so we need to take an arbitrary element out of R. And we've got to find an element y. So I'll say we need to find a y in R such that when I plug in x into my function, it outputs y. Well, based on the definition of f, it looks like we want y to be 2x plus 3. So now we just need to know why is 2x plus 3 a real number. Well, if I take a product of two real numbers, it's a real number, and if I add two real numbers together, it's a real number. So now let's write up this proof formally. So I'll say proof, let x be an R, since a product of real numbers is a real number, and both x and 2 are real numbers, then 2 times x is a real number, since addition of real numbers is a real number. And both 2x and 3 are real numbers, then their sum, 2x plus 3, is R, and y equals 2x plus 3, which is f of x. So we've verified condition 1. For every x in R, we found a y that was in R, so that when you plug in x into your function, it outputs y. So now let's remind ourselves of what condition 2 is. Condition 2 says for all x1, y1 in F and x2, y2 in F, if x1 equals x2, then y1 equals y2. So if the first coordinates are the same, you've got to show that your function outputs the same second coordinate. So let's write the proof here. You're going to let x1 and x2 be in R with x1 equal to x2. Well, since x1 equals x2, I can multiply by 2 and the equation stays the same, so 2x1 equals 2x2. And since addition of real numbers is well defined, when I add 3 to two equal values, it's going to stay equal. So 2x1 plus 3 equals 2x2 plus 3. So f of x1 equals f of x2. And that completes the proof of part 2. So we showed that f is in fact a function because we checked the two conditions in the definition.